Earthquakes, a hidden energy source for life beneath our feet. Imagine a hidden world beneath our feet, teeming with life that thrives in total darkness, powered not by sunlight, but by the very energy released from earthquakes. This might sound like science fiction, but new research from China is turning this concept into reality. But here's where it gets controversial. Chinese scientists have uncovered a surprising energy source for life deep within the Earth's crust. According to their study, the intense chemical energy released during earthquakes can serve as an alternative fuel for subterranean microorganisms. This groundbreaking discovery not only illuminates the energy needs of deep Earth ecosystems, but also has profound implications for our search for life on other planets, such as Mars and Europa. Published in the journal Science Advances, the study was spearheaded by researchers from the Guangzhou Institute of Geochemistry, Chinese Academy of Sciences. These researchers have revealed that 95% of Earth's prokaryotic organisms, which account for about 19% of the planet's total biomass, live in the dark depths of the Earth, far beyond the reach of sunlight. These organisms cannot obtain energy from organic matter synthesized through photosynthesis, leaving scientists puzzled about their energy sources. The researchers conducted simulations of faulting activities several kilometers underground and discovered a fascinating process. When rocks fracture and create new surfaces, the freshly broken chemical bonds come into contact with water, generating a significant amount of hydrogen and hydrogen peroxide. This interaction sets off oxidation and reduction cycles of iron, continuously releasing electrons. These electrons then flow between vital elements for life, such as carbon, sulfur, and nitrogen, forming an invisible subterranean power grid that provides readily available energy for microorganisms. This research not only offers a new perspective on the resilience and adaptability of life on Earth, but also provides a roadmap for future missions searching for extraterrestrial life. The researchers suggest that paying close attention to oxidized and reduced substances near fault zones could be crucial in detecting life beyond our planet. And this is the part most people miss. So, what do you think? Could this discovery change our understanding of life on Earth and beyond? Join the conversation in the comments and share your thoughts on this groundbreaking research. Are you convinced that earthquakes could fuel subterranean life? Or do you think there's more to the story? Let's discuss Unveiling Life in the Dark. How microorganisms survive without sunlight. Imagine a world where life thrives in the darkest depths of our planet, completely independent of the sun's rays. This mind-boggling concept is no longer just science fiction, thanks to a groundbreaking study by Chinese scientists. Unveiling the secrets of subterranean life. Scientists from the Guangzhou Institute of Geochemistry have cracked a code that has puzzled biologists for years. How do microorganisms survive deep underground, where sunlight is but a distant memory? The answer lies in the very fabric of our planet. Tectonic faults, those mighty cracks in the Earth's crust, unleash a chemical reaction that provides energy for life in the most extreme conditions. The mechanism unveiled. When tectonic faults move, they create fractures in rocks, releasing free radicals that split water molecules. This process produces hydrogen and hydrogen peroxide, creating a unique redox gradient. This gradient triggers chemical reactions with iron found in water and rocks, which can switch between two states, ferrous and ferric. These reactions support biochemical cycles of carbon, nitrogen, and sulfur, providing the essential ingredients for microbial metabolism. The power of tectonic faults. But here's where it gets controversial. Tectonic faults, especially during earthquakes, produce an astonishing amount of hydrogen, up to 100,000 times more than other known mechanisms like serpentinization or radiolysis. This makes fault zones a powerhouse for the subsurface biosphere, allowing microorganisms to flourish kilometers beneath the surface, in environments that would be deadly to most life forms. Redefining our understanding of life. This research challenges our traditional view of life on Earth. Previously, we believed that life deep underground was limited to energy from organic matter seeping from the surface or rare geochemical processes. Now, We know that tectonic faults create a stable and powerful energy source, capable of sustaining complex microbial ecosystems. Relevance to astrobiology. And this is the part most people miss. The conditions created by tectonic activity on Earth could be similar to those on other rocky planets, like Mars or the moons of Jupiter and Saturn. The hydrogen and redox reactions identified in this study could be our key to unlocking the secrets of life in subsurface oceans or rock formations on other celestial bodies. Future explorations. The authors of this study have opened a new chapter in our exploration of underground life. Future studies will delve into the impact of different tectonic faults on microbial communities and identify the toughest microorganisms that can survive in these extreme environments. Researchers also plan to simulate these processes on other planets, bringing us closer to understanding a potential for life beyond Earth. The impact of interdisciplinary research. This discovery highlights the power of combining geochemistry, microbiology, and planetary science. By understanding how life persists in Earth's extreme environments, we may unlock the mysteries of biospheres across the universe. Conclusion. The work of these Chinese scientists has revolutionized our understanding of life on Earth. Tectonic faults, with their unique ability to generate hydrogen and hydrogen peroxide, provide the energy needed for microorganisms to survive without sunlight. This not only expands our knowledge of the subsurface biosphere, but also offers a new lens through which to search for life in the vast universe. Their research reminds us that life is resilient and widespread, inspiring further exploration of both our planet and the cosmos. Hidden life beneath our feet. How cracked rocks fuel underground microbes. What if the Earth's toughest rocks, the seemingly lifeless bedrock beneath our feet, harbored the secrets to sustaining ancient invisible ecosystems? A groundbreaking study has revealed that earthquakes aren't just destructive. They're also chemical powerhouses, sparking reactions that feed microbial life in the deep crust far beyond the reach of sunlight. Buckle up. You're about to discover how cracks in the Earth work like cosmic faucets, gushing energy into the dark underground world. Shaken, not stirred. How earthquakes jumpstart life. When the ground quivers during an earthquake, rocks fracture under immense pressure. That's not just destructive, it's catalytic. Researchers at China's Guangzhou Institute of Geochemistry used high-pressure labs to mimic seismic events, focusing on quartz and basalt. What they found? These ruptures unleash highly reactive free radicals that split water into hydrogen gas and hydrogen peroxide, creating an energy cocktail that's 100,000 times more potent than natural alternatives like serpentinization. But here's where it gets controversial. There's debate among scientists about whether this process is rare or widespread. While preliminary experiments suggest extreme energy bursts, the study's lead author Zhao Wu emphasizes that even minor quakes, like the microtremors we rarely feel, could create microhabitats. Imagine it. We walk over chemical springs, never knowing that 4 hours of fault movement could yield enough hydrogen to sustain dense microbial biofilms. Over a year, it's 33.1 moles per square yard of energy, enough to fuel life so low maintenance that a single microbial cell can thrive on less than a trillionth of a watt. The hidden circuit beneath your feet. About 15% of Earth's biomass lives in the deep crust, a microbial metropolis invisible to surface dwellers. These bacteria and archaea aren't sunlight dependent. Instead, they exploit peroxy bonds in fractured rocks. Picture it, a spiderweb of geochemical reactions that release energy when tectonic shifts flip nanoscale switches in the rock structure. As the study team puts it, it's a self-sustaining redox cycle where rock decay becomes renewable fuel. But wait, are we missing something? The connection to iron cycling is key. Hydrogen reduces ferric iron, Fe3+, into ferrous iron, Fe2+, while hydrogen peroxide does the opposite. This seesaw game creates a never-ending energy loop, letting microbes siphon electrons then rusting rocks. Tests on granite samples confirm the process, and borehole samples from Canada's ancient shield show this iron dance plays out over years, its life thriving in record time, using the same cracks that 19th century miners feared. Beyond Earth, rock fractures as cosmic life decators. In astrobiology, spots like Mars' fractured crust or Europa's heavily tectonized shell are often dismissed as lifeless. But here's the twist. NASA's Mars rovers have already spotted redox-shifting iron minerals, hinting at similar cycles. Could the best spot to search for alien life be the cracks in the ground, not the surface oases? Glaciers offer an eerie parallel. As ice grinds basalt, it releases hydrogen, energy for microbes in subglacial lakes. Whether through tectonic chaos or ice sheet movement, mechanical stress programs the planet's chemistry. This study gives cosmic hunters a roadmap. Look where energy meets dark reactive zones. But here's the rub. Is this a universal Earth phenomenon or a cosmic oddity? If these reactions are somehow common on Mars or Enceladus, the surface may not be light's limit. It's just the beginning. Provocative Q. Could life be closer than we think? Astrobiologists, would you support missions targeting rock fractures on Mars first, rather than surface exploration? Or are we overcomplicating things? Share your thoughts below. After all, the Earth's deepest secrets might not be in the stars, but in the cracks beneath our boots.